Today, we are talking about the using the SPSS for the intermediate class. Before we are already discussed about the basic SPSS, what you want to analyze in your basic, and now today is about this intermediate is continuous from the previous basic. However, my note is already I sent to our secretariat, so maybe some of you still not receive the new my notes. Okay. However, we still waiting from the secretariat to publish or to link the note about this workshop today. Okay. The IPS asked me to discuss or to deliver the analysis of the SPSS based on the intermediate workshop. Okay. So we have the PowerPoint and the data, and I hope everybody you already have the SPSS in your computer or laptop, because we are going through by practical before we try to understand or to interpret the output of the SPSS, because this is very important when you write up your project paper or your thesis. Sometimes students are not understand the meaning of the output from the SPSS. So today we are talking about how you interpret the output and how you analyze the data based on your research question and your hypothesis. Okay, this is about my. You just read and you can get from my note. Let's note. So what is in the coaching workshop today? First, I still to recall again about the SPSS interface, because the SPSS interface is very important to you understand. So what the meaning of the all the SPSS software, especially for the version of the SPSS, because some of the version of the SPSS is different. For example, version 26 is different with the version 27. So it depends to your software. But today I using the SPSS for the version 27. Okay, the latest one is if I'm not sure, is around version 29. I don't maybe it's now is version 29. Okay? However, for me it's better you use for the version 27, because the version 27 is the new interface, especially for the analyzed data, compare for the below version 26. Okay? So today is about how we run the ANOVA, especially for the one-way and two ANOVA correlation. Okay? Sometimes correlation not only for the relationship, but we are talking about the reliability and validity. The third one is about factor analysis, because the factor analysis actually one of the method to find out or to produce the construct validity. Yeah, construct validity. And lastly is about the regression. But regression is normally for the student undertaking for the PhD level or doctor education or EDD. Okay, beside that, I still talking about your data. I assume your data is under parametric, not non-parametric. Because the non-parametrics, the other way to analyze your data and also to answer your research question and your hypothesis. But today is more to the parametric test. Okay? So remember, this workshop is only for the parametric test. Okay? I assume your data is normally distributed, especially for the from your sampling. Okay, okay, we use 5 data here from the employee data, data exam, one way ANOVA, two way ANOVA, and organizational culture. So we have 5 data here to show, to make sure you understand from the various data, not only from your data. But for this workshop, it's better if you have the own data, because from your own data, you know about the problem or how you analyze your data. Okay. So before we run the analysis data, I assume you have already know about research methodology. Okay, research methodology, especially for you understand what you are research design. Okay. Normally for the parametric test or non-parametric test, we are using quantitative methods, not the qualitative. So if you're using the qualitative method, that means you need another workshop for the qualitative method. How you analyze the data based on the qualitative data. So today is about quantitative data. Yeah? Okay, the quantitative data, that means you need to understand how you select your sample from the population. We have 2 types of sampling. First, we call the probability sampling, and second one is about non-probability sampling. So today we are talking about uh, the probability sampling. Okay? For the non-probability sampling, so sometimes you are using non-parametric test or qualitative method. Okay, that is for the non probability sampling. But today we're talking about the probability sampling. The third one is you must know how you set up your research question and hypothesis. Normally, research question develop through your problem statement. Normally, normally from your problem statement. How you will get your problem statement? Yeah. From my previous experience, student develop the research question first based on the current issues, and second one is based on the literature review or your LR. This is same with the hypothesis. In the Viva, normally some panel will be ask the student how you develop your hypothesis in your research. So make sure you know how you develop the hypothesis. I always suggest to students, when you develop the hypothesis, you need look again your LR or literature review, because from the literature review, especially from the previous research or study, you can assume what will happen of the relationship between 2 variables. So based in this study, you can develop the hypothesis. It depends. Either you want to using the uh, null hypothesis or alternative. For me, it's better you using the null hypothesis. Okay? Too easy to reject the hypothesis or fail to reject. And lastly, about literature reviewer. Sometimes when you're talking about literature review, actually you are not write up a book. eh. Literature review is about how you are synthesize. Okay, how you synthesize the previous theory, model, and also the study related to the variable. And then from this synthesize, you can understand the logical of the relationship between 2 variables. Okay? So the most important, the logical, because the theory normally, when they explain the theory, normally they using the logical method. So remember, okay? So the most important is logical. I have the experience from the couple thesis, a lot of thesis. By statistic is okay, no problem for the research method. But based on the logical, there is not logic. So sometimes you need to understand how the variable is relationship between them. Which one the first come? Which one the first come? For example, relationship between motivation and achievement. So which one the first one? Should be the motivation, not the achievement. However, sometimes the literature review will be contradicted with the logical. So it depends how you find out or write up your literature review. So the most important literature review will be guide you to analyze your data. Sometimes some supervisor ask you to write up the methodology in the literature review. So it depends to your supervisor. For me, it's okay. Either you want to write or not write your methodology in your literature review. Because sometimes if you write up about the methodology in literature review, that's mean you want to know either you want to use the same method to analyze the data, or you're using the another method to analyze the data. So this is very important when you're talking about methodology in your literature review. So it depends to your supervisor. So SPSS version currently, I know it's about the version 29, but for our workshop, we are using version 27. We go first before that. Before that, you can click the icon here to run your SPSS. Okay. After you run the SPSS, you will be go to this interface, the SPSS interface. Okay. First, we have two interface. First, we call the data view interface, and second one is a variable view interface. Okay, before we run analysis, we make sure that you have the data, especially from your data row, and then from the data row, you insert the data to your SPSS. For example, here, from the variable view, you must create the name of the variable, type of variable, and either you have the decimal or not decimal. And label and value. This is very important. The submenu in the variable view. In the data view is about you insert the data based on the code. Based on the code of data. So you need a good book or scoring guide to insert your data in your SPSS. Why this is very important? Because to easy to access the data, especially when you're talking about the respondent. Okay, respondent, because sometimes the respondent is not answer the question, especially for the demographic question. Okay, for the demographic question. For the instrument, sometimes the respondent also is not answer the item. So what happened? Normally I ask my student to make sure all the instruments should be answered by the respondent. Okay. It's okay for the demographic if the student or the respondent is not answer the demographic section, is okay. But for the instrument must be answered, because that's the very important to your data. Okay. Secondly, every student or every respondent should be have their own ID. ID number, or sometimes we call identification number for each of the respondent. Why? We need this ID to easy to find out if the one of the respondent is not qualified to analyze the data. So we want to check again why this respondent is not qualified. Sometimes respondent is not answer the questionnaire. So very important, we have the ID. Okay. Okay. If you're using online survey, you need something to identify your cases. How you identify? Sometimes you're using email, but sometimes the respondent will not give the email, okay? Especially from the outside from the university. In our university, if you're a student or you're a lecturer or you're a staff, we need your email. Because why we need your email? Because to show that you are currently participate the survey. So sometimes online survey using the Excel data. Okay, Excel data or collect the data using the Excel. And SPSS can be read or compatible with the Excel data. So that means it's no problem for the SPSS to read the Excel data. This is example for the code box. For example, identification number, you just using the name in the SPSS ID, ethnic group, maybe ethnic GP, gender is gender, income, maybe income age, and so on. So the SPSS name in the code book is up to the researcher. Only the researcher know about the SPSS name to show or to represent it to the what the variable is they are using in the SPSS. Okay, this is a very important about that. Okay. Okay, before we run the data or before you run the analysis, the most important, you must check your data. After you key in the data from all the respondent, secondly, your task is to check your data in the SPSS. Okay. What you want to check? First, you check the key values in label for each variable. It's already your key in or not or blank. Sometimes the researcher no need to key in the value and label. She or he is already, the variable is referred to what. And then you need to run frequency for each variable to show that any data is extreme or funny or sometimes is not logical, and also you can see any missing data. Okay, you're using frequency, you can know the data sometimes is missing or not missing. So you need check again. You need check again, and either you want to clean the data or what. When we are talking clean the data, that means maybe you remove the respondent, okay, from your data. But remember, please remember in your research method. If you say in your research method, your sample you need 300, your data at least in your SPSS should be 300. If you clean the data, for example, you remove 2 or 3 respondents from your data, that means your sample is not enough as you are talking in your research method. So if your data is not enough, please again go to the field and find out the another respondent to make sure your sample is enough, based on your research methodology. If you say 300, that means you need at least 300 respondents in your data. Okay, that means that 300 respondents should be clean the data. There is no funny data, there is no missing data, and there is no not logical data. So you need exactly 300. More than is okay. More than 300. For example, you have the 311 or 320 sample. It's okay. It's no problem. Okay. It's okay. More than from the 300. Okay. What I mean the clean data here is, for example, here, okay, we have the question about how old are you? Okay, for example, we have the 16,401 10 respondent. However, looking for this key value, the key value here, we found that you have the key value 8 and 9. Okay, 8 and 9. This is this value is not valid because you don't have the value 8 and 9 in your questionnaire. Right? Maybe you are wrong key in the data or the key value. Okay, so you check again why you have the value 8 and 9. Okay, value 8 and 9. Okay. The second one is the missing system. So the missing system is refer that either the respondent is not key in the data or write up the data, or you are not key in the data in the SPSS. That means we have the missing data. For example, here we have 66 respondents have not key in this data. So this is a problem. Okay, but because this is the data for the what we call is for the demographic, is okay, no problem. Sometimes the respondent are not insert or select the exactly answer in your questionnaire. Okay. However, if you need to make sure all this data is filled in, so you go back to the ID to check why the respondent is not key in the data. Okay. So this is very important when you to check your data. So you need the run frequency and SPSS to make sure your data is really clean from the problem. Okay. Okay. I assume our data is from the probability sampling, at least 30 sample. For the parametric test, normally we using a minimum sample is 30. Below 30, we assume you using non-parametric test. Okay. So the parametric test, we assume normally at least 4 assumptions here for analyze your data. First, about your data should be normality distribution. So how you check the normality distribution? Normally you will using the Yunus and kurtosis or Kolmogorov-Smirnov and Sapir-Whorf. But normally I find out the student more popular with the Yunus and kurtosis. Compare the using Kolmogorov-Smirnov and Sapir-Whorf. It's okay, but you must give the justification why you use Yunus and kurtosis compared with the Kolmogorov-Smirnov and Sapir-Whorf. Currently in the Scopus journal, some of the literature I found that they're using both of these method to show that their data is normally distributed. They're using both this one. They're using the Yunus and kurtosis, and at the same time they're also using the Kolmogorov-Smirnov and Sapir-Whorf. This is for the single variable normality test. For the multiple group in the same variable, we using test we call the homogeneity of variances. Normally, when you are talking about the ANOVA, also we are talking about the regression. We also use the homogeneity of variances test. Sometimes we call this test is a leaven test. Okay, we call this a leaven test. The third one is about the linearity among the variable. So we need the data have a linear relationship. That means your data is should be ratio or interval measurement scale. If you using the categorical or nominal data and ordinal data, that means your data actually is a not linear relationship. Okay, so that means you need to the non-parametric test. And lastly, the independence of the data. Okay, the independent data is that means is every data is stand alone, not independent for the another pattern. Okay, so we need this data. So you have this one. The assumption that means you will be run the parametric test. Okay, normality test, skewness and kurtosis, and also about Shapiro weight. For the Shapiro weight, normally we using for if your data is below 50 samples. But Shapiro weight also can test for the more than 2,000 samples. 2,000. But normally the PhD student or master student, they have around 100 and 300 samples. That means you can use the Komlov-Smirnov. Okay? The Komlov-Smirnov test compared with the Shapiro weight. So how you run the skewness and kurtosis? Can you open the data exam? So this is the data exam. We have the 40 student here, data view, and this is the variable view. Okay, so before you key in the data, you must create the variable. First is student. Students is report the student number. This one, student number. Okay, the SPSS code, the preparation is referred to hours of preparation. Relax, refer to hours for the spend relaxing. Commuting is hours to spend the commuting. And mark is about your examination mark, okay, or your achievement. Okay. Okay. How many sample is there? There is 40 sample. That means if you're using the Komlov and Smirnov, that means we're using Shapiro weight. Because below 50. Okay. Then we check either this four variable is normally distributed or not. So how to check? Go to analyze. Click descriptives and explore. Okay, it's already there. Correlation is very simple analyze, but there are multiple purpose why the researcher using correlation. Okay. Correlation is about the relationship between two variables. Okay. But remember, your variable should be in continuous data or interval data. You can try the relationship between nominal data to the continuous data, but you are cannot using the correlation method. You are going to using the what we call is chi-square correlation. This is from the non-parametric data or non-parametric methods. So, but for the parametric data, your data should be either independent or dependent variable, should be interval or ratio measurement scale. We using correlation in parametric. So the technique is give one number. Okay, the correlation coefficient we call the correlation coefficient, or sometimes in bahasa Melayu we call pekali korelasi. Okay, so the correlation coefficient is equal to high number in one variable. For example, independent variable will be tend to be higher also to the another variable. That's mean for the dependent variable. We call this one is a positive correlation. So if the A higher, should be B A also higher. That means it's positive correlation. Or if you have the higher number in the independent variable, but you have the lower numbers in the second variable or dependent variable, we call negative correlation. So we have two correlation here, positive and correlation. And also we need to know how strong and significant your correlation, either positive or negative correlation. So that is how you calculate the correlation. So in a parametric test, normally we use Pearson correlation calculation. For non-parametric, especially for the ordinal data, ordinal data and interval data, we are using the Spearman rank correlation or Kendall rank correlation. Another one we call Cohen-Kappa. Cohen-Kappa is about the reliability. To check whether your two of your instrument is reliable or not reliable. Also, we use the Cohen-Kappa. That means we normally the student using this one to for the judgment. Usually, all the four variables except the student numbers, but because the student number is ID, okay, it's ID. So you need all the four variables. Okay, the display is both click plots. Okay, click plot. So uncheck the stem and left. Vector label together and also check the normality plots with test. Okay. Continue and OK. So this is the output. This is the output. Okay. We have the 40 sample every of the response, every of the variable. There is no missing cases. That means all the respondent key in the data. And now we are going to check the skewness and kurtosis. Look this one. Number one, skewness and kurtosis here. Okay, we found that the skewness, especially for the kurtosis, is very high, 16.0. Normally, based on the hair, they suggest you need around plus minus 1. But sometime from the previous literature, I found that some literature suggests plus minus is 2.5. So we found that is the data for the hours of operation is not normally distributed. Okay. How about the hours of spent relaxing? It's okay. There is no more than 1. Okay. Hours spent computing is okay also. It's not more than 1. How about the examination mark? Also is not more than 1. Okay, we go to the test of normality from the Kromberg, Smardov, and Shapiro ring. Based on this data, okay, if you have the significant, you have the significant statistic at the Kromberg or Shapiro, that means the variable is not normally distributed. If you have that significant, but from this one, we found only one variable is not normally distributed. What is the variable? Hours of the preparation. The other one is a normally distributed. We look for the significant label here. We found out this one is not significant, also not significant. Examination mark also not significant. In the Sapir work, also for the relaxing, computing, and mark result is a not significant. Only the hours of preparation is a problem. Okay. Why this variable is problem? Can you check for other output? From the QQ plot, okay, all the dot is nearest for the line here. Only one here is not nearest for the line. So we have this is the very high value. Okay. So this is very extreme value. Okay. And the other one is okay, this one. And from the box plot, we found that only one respondent is a problem here. The others, how? We go back to the data. If you go to data, we found from here, this one, hours of operation. We have the star here, and the mention is number is 13. So 13 here is referred to the number of respondent. Okay. Why this respondent is very extreme? We go to the data first. This respondent number is 13. So you look this one data. It's a very high, 198. Compare the others, more similar about them. So what is your discussion or your decision? Are you want to remove this respondent or you maintain this respondent? Respondent to analyze your data. So here we have is a more than 30. That means you can remove this respondent. For example, we try remove this one. So we have 39 respondent here. So we run again. Just Yunus and kurtosis. Analyze. Okay. Audit. We must save as because you are already to delete the respondent, so you need the new file. New file. So that means the original file is still there. Okay. So we need data exam 1. Okay, we try again. Go to explore. Right. We have the 39. So look this one. Even though it's more than 1, but it's still acceptable because of the data. Also, it's below 1. This one is below 1. So, okay, we look this one. we still found that the superior is significant. Okay? Significant. But for the cum-laude Smarno, it's not significant. Okay? It's not significant. It's not significant. Only for the superior work. Why? Look, this one is okay actually. No problem. If you go to this one, it's no problem, the data. It's no problem. So we assume that your data is already normally distributed. Okay, normally distributed. So that's the analyze how you check out or to find out whether your data is normally distribution or not. Some of the panel or some of the journal ask the researcher to check. They want to ask the researcher or the writer to mention about the effect size. Okay? The effect size and interpretation. For example, if you have the correlation, they want to know the effect size for the correlation it is small, medium, or large. For the t-test, also the ANOVA, chi-square, and F2. So this is sometimes the researcher or the journal, they want to the writer give the effect size and interpretation. But it depends to the panel and also the journal. But currently, some of the journal is already to mention this one. So you must prepare about this one. That's why when you're going to the version 27 SPSS, they already also to provide the effect size actually. Okay, compare below version 26. Okay, we go to the one-way ANOVA. Yeah. For the basic, they test about the t-test to compare two categorical data. But for the one-way ANOVA, you are using to compare group, right? At least three component or three categorical variable. Or minimum is two groups. But normally when you use the one-way ANOVA, you are independent variable. Your group should be at least three group. For example, for the location for the school, we have three location for the city or urban area, suburban area, and rural area. So that means we have the three groups to compare which one the more better or any difference between three of the groups. So we call them is a one-way ANOVA. However, before we interpret any difference among them, besides we test the normality test, we also test for the homogeneity test among the group. So your variance in your group should be similar, or there is no difference between group. So this is the basic for the one ANOVA. We need the homogeneity test. That's why sometimes the panel will be asked the student, there is any different variance in the group when you run the ANOVA test. So sometimes the student cannot answer this question. It's very simple question actually, because if your data is not homogeneity test, homogeneity variance, that means you need to the non-parametric test. Okay.
Sorry, Dr. Jamal, can you repeat the question?
Which one?
The one that you said just now, that the panel always asks.
Sometimes the panel will ask the student, Okay, any homogeneity variance among the groups. Okay, because this is very important to show that if your variance in among the group is not similar, that means you need to change your analysis, not one way another. You go to the non-parametric test. Even though you have the already your data is normally distributed. Because normally for the skewness and kurtosis, they analyze the data is all together, not by the component or by the group. But when you run to the for the ANOVA, they need the homogeneity test, because if your data is not homogeneous among the group, that means something wrong or something data will be extreme in your any of the group, maybe group A, group B, or group C. So we need clear that homogeneity must be across all the groups. It's a very basic actually. Sometimes the panel will be asked, but before the panel will be asked, normally the supervisor will ask you. So you need to find out why. Sometimes I had the problem this one when the student have the homogeneity is not same across the group. Why? Because maybe one the group from the three the group, one the group is have one sample. The other group, for example, group one we have one sample. The other group two we have that 20, and group number three is about 30. So there is not equal among the group. That's why your homogeneities among all the group is not similar, because group number one you have only one sample. One sample. So what I suggest for the student, I ask the student if you want to also to check the comparison between group, you need check again about the one sample. I want to remove the sample, or you move the sample to the either to group number two or number three. So you have only two groups. If you have that two group, that means you are no need to run the one way over, but you go to the t-test also to compare the difference between the group. So you check again about the total number of respondents of each of the group in the all the groups. So normally I found that why the homogeneity is not same across the group, because the number of each group is not similar. Last Viva, I found this one. Okay, I asked the student why the homogeneity test is not similar among the group. Okay, I already know about this one because I found that the one of the group only one sample. Okay, so make sure that all the group, in case you need more similar among them. Okay. For example, group one maybe 10% or 10 respondent. Group two is 20. So this is a one-way ANOVA data. Okay. So this is a very view. We have the city and the cost. So city is referred to the four city here. That means we have the four group here. It's more than three. So we have the Adelaide, Melbourne, and Perth. And the label for this cost 1000 to cost of electricity and the gas. Okay, so what is the problem in our one way ANOVA? This one. Example, the economists wish to compare the household expenditure on electricity and gas in 4 major cities in Australia. She obtained random sample. Remember, if you run the parametric test, your sample should be random, not convenience or purposive sampling. Convenience and purposive sampling is more non-parametric test. So you need the random sample. Random sample of the 25 2% household from the each city. That means you need 25 respondent each city. And ask them to keep records of the their energy expenditure over a 6-month period. A 6-month period, not 1 month, 6-month period. To get the mean score for the 6-month period. And test any difference among 4 of the major cities based on alpha 0.01. Sometime in social science, we're using the 0.05. Okay. Remember why? Why the 0.01 or 0.05? It depends to your sampling error. Depend on your sampling error. So, how to run? Okay, we go to the data. Go to analyze. And complements. Then go to one way ANOVA. Where's one way ANOVA? Is here. Okay. What your dependent variable should be? Your dependent variable is a cost of electricity and gas. Why? Because this data is continuous or interval data. So normally the independent variable is a continuous data. So you bring to the dependent list. Okay, before I forget this one, normally dependent variable is your main of your problem statement in your research. So anything about the problem statement variable is about your dependent variable, not your independent variable. But sometimes students are confusing which one you want to show that is your problem. Okay. For the quantitative, normally dependent variable is your problem in your research. So that's why you want to check why this dependent variable is very important. Okay? And the city is we go to select and bring to the factor. Remember this one? I already mentioned about the effect size. Estimate effect size for overall test. So maybe you want to check or not check. It depends to you and depend your supervisor. Okay. Okay, we click the phosphor here. And the phosphor. Okay. So there's so many equal variance to assume. Normally we're using the 2 key here. You click 2 key. And go to the null hypothesis test. Okay. The researcher need to the specific significant label is 0.01. So you click here. You need to change here from 0.05 to 0.01. Continue. Click. Okay. This one. Okay. Okay. Based on this table ANOVA, we have the F value here is 3.802 and significant level is 0.013. If you're using 0.05, that means there is significant. But if you're using 0.01, it's not significant. Okay, I repeat, if you're using the alpha value is 0.05, that means these ANOVA tests are significant. But in our workshop today, we're using 0.01. That means your label is not significant. So it's up to you. Either you want to using the 0.01 or 0.05. Normally, for the normal science, for the social science, we are using 0.05. 5% only is a sampling error. Okay. For this ANOVA effect size. So what is the effect size here? This 0.1. Can you check our effect size before this? For ANOVA, this is 0.01. Our point here, 0.1. Okay. That means it's very large effect size. It's very large, but that means not because of the sampling, but it's a true data that to show there is difference among the cities actually. So there is very large effect size. Okay? Here. So which one is a different? You go to here, multiple comparison. How to check the comparison? You go to the significant value. Any significant value below 0.05, that means is a significant. But here, the SPSS mentioned the mean difference is significant at the level 0.01. So below 0.01 is here. So the difference among between Adelaide and Perth is here. How many different among them is $57 for the 6 months between two these cities. Okay? The rest is not different among them. Only for the Adelaide and Perth. Okay? So you looking for the significant value is there. For example, here. Okay? Okay? That's it about one-way ANOVA. How about two-way ANOVA? Okay. One-way ANOVA is about we only have one independent and one dependent variable. But two-way ANOVA, that means we have two independent variable and one dependent variable. Remember, two independent variable is referred to the group data, not for the continuous data. For example, variable number one, we have the three groups, and the second independent variable, we have three groups. So independent variable is here referred to the grouping of two type of variable. Okay, and dependent variable still the continuous data. Okay, okay. For example, here a toy company, Torignum. The name of the company is a toy. Manager productivity is reflected in the cross of the various store type and location. Each manager oversees 6 stores. One of the type is in each location. You wish to determine that the effect of the store type, variety, department, and discount. and location, city center or suburban on productivity. Measure as a sale of toys. So we have two independent variables. Number one is about the store type. We have three types. Store is there, is variety, departmental, and discount. And location, we have two group only, city center and suburbans. And our dependent variable is productivity. So productivity is measured by sales of the toy. You have four questions. If you run the two-way ANOVA, you have four questions actually. But sometimes students are using two questions only. Yeah? Question number 3 and number 4 normally. But you can add another question. For example, here you have four questions. Number one is, does the store type influence? The store type influence the toy sale? Or the store location actually influence the amount of the toy sold? Or number 3, the influence of toys, store type on the amount of toys sold depend on the location. Then it's about something mediator or moderator variable. And does the store type and store location impact the amount of the toys sold? That means you mix two variables is together to the amount of the toys. So this is the ROS and HO. Okay. So remember, you need to develop your RQ and HO. Okay, can you open two-way ANOVA? You have the two-way ANOVA data. The two-way ANOVA. Okay. From the variable view, we found three of variable here: location, type, and cell. Location is about location the store. Okay. Types, what type of the store? Okay. And sales, a toy sells $1,000 per week. Okay. So location of store here refer to two group only, city and suburban. Type of store, we have three type: variety store, department store, and discount toy. Okay. So what we to do to run the two-way ANOVA. So we need to univariate analysis. Okay, back here, analyze, go to the GLM. Now, compare means you go to the GLM, sometimes we call general linear model, and using the univariate analysis. Okay. So what is our dependent variable? Dependent variable is toy sales. Remember, the toy sales is about the interval data. Whereas our manual, the location and type is a fixed factor because these are not continuous data, but they are category data or nominal data. Okay. What else? You click option. Only click the option. So what we want to check here? Click descriptive, estimate of effect size, observe power, homogeneity test, and significant level 0.05. The rest is okay. Continue and okay. So this is the basic data for the descriptive only. And also this is a descriptive statistics data is about mean score and standard deviation. And the living test is about the homogeneity test. We found this here is 1.00 and not significant. That's mean across the independent variable is a same variance among them. And when we are looking for the number here is a equal 4, okay, that's mean the variance of each of the categorical is a same. Okay. The most important here is to show it's not significant. It's significant. That's mean one of the variance in of your dependent variable is not equal among them. So make sure this is a not significant. And and now we are going to the here. Okay, how to interpret? First, we go to here location, type, and location and types together. So we go to location and look for the F value 1.30 and the significant value is a not significant. That means location is not influence the toy cells. Can you answer the this one? So location is not influence the toy cells. We already answered the question number 2. Type. Type of the store. F30 3.055 and significant 0.072. Also is not significant because it's more than 0.05. So question number 1 also the store is not influence the toy cells. Number 3, does the influence store type on the amount of cell depend on location? So this one we going to the another analysis, but we want to answer number 4 here. Does store type and store location affect the amount of bytes? We go to here. Location and type. The F test or F value is 3.927 and significant value is a 0.038. That means it's below 0.05. So here we found that location and type actually is influence to the toy cells. Okay, toy cells. How much? How much? How much these two variables influence the toy cells? We go to the here, R square here. R square here. We found that 45.9 or 46%. 46%. The location and type variable was influence the toy cells. Okay. The rest, 55% is another variable. So what is another variable? So maybe you need the another research to find out either the another variable also influence the toy cells. But this case we found nearest 50%, nearest the 50% location and type was influenced to the toy cells. Okay, the toy cell. Okay. How about the here? Number 3. So another here. How to you check this one? Nice. Okay, model. What is the moderator there? Location. So we need location here. Location. Okay. Unit back. Okay. Continue. Okay. Real time. Okay. Try again. Tell me. Yeah, it's here. Okay. See, we found that the location is not influenced to the location is not influenced as a moderator between relationship between the type of the store and the toy sales. So because these are not significant here. These are not significant here. Okay. Normally the student using this one. Okay. Together the independent variable location and the types one. Okay. So this is observed power. Observed power is normally is referred to the how strong how strong the variable influence to the toys sense. So when we are looking for the location type, we are 0.6. Okay. It's very high compared the type and location. Okay. And then this one R square. Remember R square, we again the end of this workshop we go to the regression and how to interpret the R square here. Okay. From this two-way ANOVA, we found that around 46 or nearest 50%, the location and type was influenced to the toy cells. Okay, correlation, reliability test. So this is a positive correlation. If you high number and weight, also you have the high number of the head. So we call that positive correlation. And how strong is depend to the value here. So the value is from 0 to 1 or 0 to -1. The strong of the relationship between two the variable. Is here how to interpret the rank correlation coefficient. The symbol sometimes we show the small letter R or capital letter R. Normally, small R is referred to the correlation, but for the R also is referred to the Pearson correlation, but in the SPSS regression. The same also to show that correlation. Okay. So positive one is a very high correlation or negative one. If you have the 0, that means you have no correlation between two variables. So this is the value to show whether your correlation is very weak correlation, moderate, strong, or very strong correlation. Either you are using the negative correlation or positive correlation. It's the same meaning. Or sometimes the student using this two types of the interpretation of the strong of the correlation. Either they're using the Scober boy and Scovate, or they're using Selkin. Okay? Selkin 2007 and Scober boy and Swate is 2018. It depends to you which one you want to using or your guideline to interpret your correlation. Normally, I found that student most popular using the Salkin 2007 is more acceptable to interpret the relationship between two variables. Okay. For this course, we're using this one, the Salkin. Okay. So this is another way to interpret the strength of the correlation. Okay, Pearson correlation. Pearson correlation is most common correlation coefficient among the researcher, especially from our student. But before you run the Pearson correlation, we need to explain that two of the variable is normally distributed and quite enough for the sample. Pearson correlation is at least 30 sample. 30 sampel ataupun 30 orang responden need 30 sampel to run the Pearson correlation. If you don't have the enough 30, maybe you use the Spearman or Kandel correlation because below 30. Okay, if you have the quite enough, it's okay. You're using the Pearson or Pearson correlation. That's why sometimes the supervisor asks the student, if you run the pilot test, you need at least 30 respondents. Why? Because the Pearson correlation is sometimes also referred to the reliability test. Okay? Reliability test. To test that your instrument is reliable or not reliable. So you need at least 30 respondents and your data should be normally distributed. Okay. Okay, this is how the Pearson coefficient correlation to net by either -1, more than, or less than half. Okay. Negative or positive? You should keep the sign either negative or positive to show the direction of the correlation. If you give the sign negative, that means your correlation is a negative correlation. If you give the positive sign, that means your correlation is a positive. Okay. So either negative or positive, your correlation based on the analysis from the SPSS. Remember, from the SPSS. Okay, this is the assumption I mentioned before this. What variables should be normally distributed? Number 2 is linearity, straight line relationship between two of variable, and then homoscedasticity. That data equal distributed among the regression line. Among the regression line, the data is equal distributed. Okay, so this is the basic assumption for the correlation. So you check here, how you check the assumption for linearity? You can check from the QQ plot or histogram. Normality, you can check from the skewness hypothesis. Okay. And how to check whether your data is okay or not? Using Gaussian or PROF scraping. Sometimes the high level you need to put steps or CI confident table. That's why when you are using for the SPSS version 27 and above, sometimes the SPSS suggests you need bootstrapping or not bootstrapping. To check whether your data is normally distributed. Okay, example here. We have the student 39. We have the 4 variable. and to check if there any relation between relaxing and examination. And we go back to the data examination. So we already done relaxing and examination. Analyze, you go to correlate and click by barrier. Okay, this is very important, by barrier. So we go to relaxation first. Okay, relaxation. And don't forget, correlation coefficient, we refer to the Pearson here. If you want to bootstrap this here, remember, for the seven we don't have the bootstrap confidence interval. Therefore, you have the bootstrap. How much? Okay, normally for the SPSS version below 26, we don't have the bootstrapping and CI here. But after version 27, we have the bootstrapping and confidence interval here. It depends to your supervisor and current research. Sometimes they need the bootstrapping and confidence interval. But for your workshop, we are just only using the option here. So option here, you need to mean and standard deviation only. Okay, we go back to our review. So you need the click here, Pearson, and option, and click OK. Can you check the result? So this is the result. Okay. So our sports span relaxation is mean score is 126 minutes, and standard deviation 6.8. Examination mark 2.5. So how to interpret? First, we go to the here. We have the 39 is quite enough because correlation it at least we need 30. So 39 is okay. And the correlation between the hours for spent relaxing and the examination mark. So we have here is a negative 0.391 and significant. So what is the mean about this correlation? That means if you more spend for your relaxing, that means your examination mark will be dropped. So more relax, your examination mark will be dropped, or more than it lower. But if your hour of spent relaxing is reduced, your examination mark will be increased. So this is the mean of the negative correlation. So that means for your study, please don't more spend relax. Please reduce your relax to give you a higher mark, okay? Especially for your project paper. Okay. So this is what we call of the examination and our spend. Okay. The others data, for example here, we try look if either the hours of preparation will be also impact to the examination mark. So you select this one to bring back to the independent variable and click here. Hours of preparation is a positive or negative relationship. Still using the Pearson correlation. Yes, is here. Hours of preparation is a positive correlation between the examination mark. We found 0.455. Before that, is here 0.391. based on the strong, yeah, it's a moderate relationship. It's more moderate relationship because it's a near to 4. It's also is also 4 is moderate relationship, but this is a positive relationship between hours of preparation and examination mark. Okay? That means more hours you spend for your preparation, your examination mark will be increased. That is mean about the difference between positive and negative. And significant here. Remember the significant, if you get 0.004, that means your significant level is 0.05. It's more lower from the 0.05. Okay, we try using the bootstrap just for the knowledge. Okay. Anything different among them? Okay, we click the bootstrap. Try for 1,000 sample because we have here only 39 samples. So we reanalyze for 1,000 sample. Okay, 95 percentile. No, you using the BCA, bias corrected accelerated. Okay, continue. Confident. You using the 95%. Dealer headline patient normally we using. So what happened? Okay, it's finished. You need a lot time to calculate for 1,000 sample based on 39 sample. Okay, this is our specification or requirement to bootstrapping. So this is the finding. Mean ours is here is already BCA is okay, no problem. And we go to here. We found that there is no problem. Either you're using 39 sample or 1,000 sample is also they have the 0.455 coefficient correlation and significant at level 0.05. So it's also the same result. In here, confidence level between lower and upper, but the Pearson correlation here is between this one. So the number is between 0.163 and 0.64. So the 0.4 is between this level. So there is no problem. That means your data is accurate and reliable. Either do you want to test 39 sample or 1,000 sample? The result is the same. That means you don't need the 1,000 sample because the result also same with the 39 sample. So that's why sometimes the journal need to the bootstrapping to show that your sample is accurate or not for the resampling, maybe 1,000. Normally, I ask students to do this program for the PhD student because we need that you select the sample is quite enough or accurate for your data. Okay? For example, if you have the 200, but we need more sample using the bootstrapping. Normally, I ask the student 1,000 or 5,000 resampling to show that your finding from the 200 sample is similar with the resampling to 1,000 sample. Okay, from this our workshop, we found that they are the same result. Either you're using 339 sample or 1,000. So that is the purpose for the bootstrapping actually. Okay. But for the master student, just only run a normal run. You don't need to double steps or resampling your data. Okay, because it's already is there for the master student. But for the PhD student, yes, sometimes I ask the student to test the bootstrapping to say either your sample is accurate or reliable for your data. Negative is there. Okay, Spearman rank coefficient of correlation. Okay, why we need Spearman rank coefficient correlation? Because maybe one of the variable is not normally distributed. For example, variable A is normally distributed, but your variable B is not normally distributed. So we need the Spearman rank correlation. That means one of the variable will be re-ranked from the smaller value to the higher value, or vice versa. The Spearman correlation will be from the higher value to the small value. It depends. Okay. So this is more to the Spearman correlation. Or your data. Your data sometime one of your variable is continuous or interval or ratio, but the another variable is ordinal data. So we need a Spearman correlation. For example, the examination mark and one other variable is about how strong you agree that the importance of the teacher in the teaching. So important, the agreement is from 1 to 5. So 1 to 5 is ordinal data. So we want to correlation between the ordinal and the continuous data. That means we need to run the Spearman correlation, not the Pearson correlation, because one of the variable is ordinal. If your data, both of data is continuous or interval or ratio, that means you need to run the Pearson correlation. So there is the difference between Spearman and Pearson correlation. Okay. So the data for the Spearman is not continuous, not need to reality, not heterogeneity, and no need to test the normal distribution. As a pre-distribution, sometimes the researcher call or the statistician call is a pre-distribution. Okay? For example here, we need here example here, the correlation. We use a Spearman correlation is 0.3. Yeah. Okay. This is for example, not for the real data. Okay? So you run that Spearman. How do you run this one? So you go back your data, analyze, relate, partial. The same one, only you change from the Pearson to Spearman. For example, yeah. So it's already there. They're running for the bootstrapping. Okay, here is yes, Spearman. Right, 39 data based on this PowerPoint is 40 actually. So from the 40 to the 39, the result will be different, even though one sample. Okay? That's why when you run the ANOVA to test the variances, one sample will be deeper from the another sample. Okay, that's why we need to check again your sampling is accurate or not equal between all the groups. Oh yeah, actually this one. So we need about this one. The data is there. Spearman correlation. Okay. Okay. Number 3 is about candle rank correlation. Based in 1955, rank correlation coefficient evaluate the degree of similar between two set of rank give the same of data. Okay. The candle rank correlation, if you are using what of the data is ordinal data. For example, here it is our ordinal data 43, 43, 43, 22 is the ordinal data. These are not interval or we call ratio data. So make sure your data is based on ordinal. That means we're using the candle tau correlation. Okay, based on this data, and your data is not quite enough, the sample. So below 30, that means we have the deep thin data here. So when we run the data, so we need the candle tau to correlation. So we found that here, the certification is very weak correlation between certification and royalty, and it's not significant. It's more than 0.05 here. So that's why sometimes they call the candle tau correlation also for the non-parametric test. Okay? Non-parametric test because the problem of the data. Problem the data and problem the minimum sample. Okay. Some students ask me, okay, if you're using the ordinal data to correlate to both of the variable, but we have the quite enough the sample. For example, we have the 100. We are using the Pearson correlation or candle tau. We still use candle tau because of the characteristic of the data. The characteristic data is still using the ordinal data, even though you have the quite enough your sample. Right. Except if your data you transform to the interval or ratio data. Okay, that means you need to run the Pearson correlation. So that is the difference among the three of this correlation. Okay, the another one we call the kappa cohen. So kappa cohen we refer to this topic is about reliability. Okay, so reliability is show to how reliable your instrument, okay, based on the difference of the instrument and difference of location or difference of the time. So if your instrument is reliable, that means your instrument will be tested without consider about the different respondent, different location, and different time. So how you check the reliability? Normally reliability we using the alpha cromba. Alpha cromba to show that your data is reliable or not reliable. However, correlation can be tested the reliability of the instrument. First, we call that retest reliability. We have two time 1, time 2. How long between two time? It depends. Some researcher they suggest around 1 to 2 weeks to check any difference value if you test twice for the different time. Okay, so different time. So you need to test time 1 and time 2. So you correlate between two this time. Or sometimes you need to test pace between two time. Any difference between two or no difference? Normally when you test the test pace, we need a significant. We need a significant. But for the retest reliability, we need not significant between time 1 and time 2. For example, here we try to test uh, this instrument, teacher's sense of efficacy scale, Jamal, Moran and Hoy, 2007. So you need test this instrument for the first time, and after first time you need more than 1 week or 2 weeks, you test again the same instrument to the same people. So you correlate. If you have the more than 0.8, okay, 0.8, that means this instrument is reliable. Reliable. But normally our student never try this method because we need time. So normally they using alpha chroma to test their instrument. So this is the first method in the correlation to test either this instrument is reliable based on the 2 times difference. Okay. So we need the stability of the test, even though it's different times. At least 0.80 or sometimes some researcher or statistics say they need at least 0.85 to show that your instrument is stable between 2 time difference. Okay. So you measure instrument at 2 times for multiple person, compute correlation between two measures, and assume there is no change in the underlying trend between time 1 and time 2. That means your instrument is no need to change. You using the same instrument to test between 2 time difference. Okay, the second one we call the parallel form reliability. This method we need 2 types of the instrument, but this instrument measure the same construct. For example here we have 2 instruments, but this instrument, both of the instrument, the measure of the teacher self-efficacy. Teacher self-efficacy. For example, here, Jamal, Moran and Hoy, 2007, they have 24 items. And other is 1998. Also, from the Jamal, Moran, Wolfo and Hoy, to measure the teacher self-efficacy, but they have 12 items. They have 12 items. Okay, so you test across between to this instrument. Okay, if you have the correlation between two the instrument is very high, 0.85, for example, that means both of instrument is actually measure the same construct. Measure the same construct. So, as a researcher or student, PhD or master's, you need to make decision. Which one instrument are you using to measure your teacher self-efficacy? For me, it's better you using the less item between two of these instruments. For example, here, form A, they have 24 items, but form B is a 12 item. It's better I using 12 items because it depends to our respondent. Sebab sometimes our respondent is not compatible to answer the questionnaire if the item is a lot of the item, especially for the psychological item, especially for the psychological items. So here, it's better you using 12 items. But still remember, in the Bible, sometimes the panel asks you, why you are not using the new one? The new one for here, for example, is teacher sent of efficacy from the teacher man Moran and Hoy to 2007 is the new one compared with the 1998. So you need the justification why you need using the 12 item compared to 24 items. Okay? Normally, the student will be answer based on the attitude or the characteristic of the respondent. Okay? The respondent is more willing to answer the item if the item less than, maybe less than 40 item or 30 item. So you need to find out the item is compatible with your respondent, especially if your respondent is for the children below 18. For example, below 18 for the SPM student or STPM student. So normally they need less the item. But for the teacher, they are not willing to answer your question if you are you send the questionnaire through the online. Normally, they want to answer your questionnaire through the online. It's better you print out the questionnaire and give to the teacher to answer your questionnaire. It's better, because this is a attitude or characteristic of the teacher in the Malaysia. I don't know for the next previous years, maybe the teacher will be changed the attitude to answer the questionnaire. Okay. Administer work from the same people. Get correlation between two people, usually done in educational context. Yes, this is more to test. Sometime from the Ministry of Education. Sometimes Ministry of Education, they try to test both of the examination paper. They have two type of the form of the examination paper, and then they try out from the pilot sample, and the two of the type of the examination paper is the same result or different among them. So normally this is very accurate in the education. So how you use you can see from the YouTube here. I already give you the links one. Okay, Coin Kappa. Coin Kappa also using the correlation, but Coin Kappa is more to measure the consistent between the iterator or director of the instrument. Okay, especially for the categorical item. For example, item 1, they said yes or no. Only two choice here, yes or no. Yes or no, no or yes. So they're using the Cohen Kappa here. So how to interpret the Cohen Kappa coefficient to show the reliability? So we have here the categorical based on the three of the scholars, Landis and Koch, Place and Altman. So which one more better? Either using Landis and Koch or Place or Altman. I think you using for the Altman, the new one, 1991. They have five uh, categorical to interpret the coin kappa coefficient. For example, here below 0.2 is very poor, 0.21 to 0.4 is fair, 0.41 to 0.60 is moderate, 0.61 to 0.8 is good, and 0.81 and above is a very good. Try to get 0.1 and above. Okay? It's very good for the your item reliability. For example, here, okay, you have the 10 item. 10 item, you have two rater. Rater number one, rater two. Who's the rater? Normally for the expert judgment. Okay. So one is normally referred to yes, zero is referred to no. For example, here item one, the item when they read the item, they said yes, the item is accurate to measure. So rated two also one. So depend on. But item number seven here, item number seven, we found that rater number one said the item number seven yes accurate, but rater number two is not accurate. So that means something here, item number seven is to show that there is not consistent rater between two rater. To between rater. So how to run this one? So we need data to run here. Go back to this. Can we open the new data? New data. The data here. So item 1 to 10, we call the item rater 1, rater 2, decimal no need. Okay. And then you fill in the data. 1, 6, 7, 8. So rater 1 say 1, 1, 1, 0, 0, 1, 0, 1. Rater 2, 0. So this is your data. So how to run? You go to the cross step. Okay. Okay. Analyze. Step. Cross step. Rater 1 bring to the row. Rater 2 bring to columns. Go to statistics. And click kappa here. Okay. There's so many there, but we click one here, kappa here. Continue. Okay. So this is output. Okay, rata 1 10 item. This is your rata crop step. And we go to the measure agreement. Value 0.5. Oh, but it's not significant. It's not significant. But it's not problem about the significant and significant. We need the value. Okay, the value. So when you are looking for the value, here, whether you're using Landis Scotch or place or element go, to show that moderate. Go to the moderate. For the element is moderate. 0.5, okay? And 0.524 is a moderate. Okay, it's here. Also, this is a moderate. If you go to Landis, you're going to the place is also moderate. So 3 of these scholars show that if you got a 0.5, that means it's under moderate. Okay, that's it about the correlation. Okay, speaking about the validity, sometimes researcher also ask, how about your validity? For the master student, we need at least you try out the face validity. Or in bahasa Melayu, we call kesahan muka. So what is a face validity? Face validity is about from the judgment expert to show that item is measure the construct. Measure the construct. For the master's MUE or for the research, poly research, I suggest you using the content validity. Also is from the expert judgment. From the expert judgment. They're using for the value of cumulative to show that contents for the item is a valid or not valid. For the PhD and EDD, I suggest you using construct validity. Okay, construct validity, we're using the exploratory factor analysis, or sometimes we call it EFA. So SPSS can be do the EFA or exploratory factor analysis. So the difference between concurrent, construct, and content validity. Concurrent validity is pertain to the ability of the survey to correlate with the other measure that the same already validated. So, for example, you develop a new cell efficacy and you correlate with the established cell efficacy instrument by Bandura. If the correlation between two variables is higher, that means the new cell efficacy is the new instrument was developed also to measure the cell efficacy. Okay, that is what we call is concurrent validity. For the content validity, normally checked by the expert judgment to try that the content validity is accurate for the content based on the psychometric concept. For example, you are teacher, you are geography teacher. Okay, the geography teacher, you develop a new test to test the geography content for the student. So to make sure your content is accurate for the geography knowledge, you need the judgment expert. So who is the judgment expert? The judgment expert is he expert not only expert in terms of the content of the knowledge, but also expert in psychometric concept. So psychometric concept is based on your psychological to test the content. So we need the expert judgment. Normally, the expert judgment is from the lecturer, because the lecturer normally will teach the content of the knowledge, and the second one, they are using the psychometric to make sure that the student understand the content based on their communication delivery. So we need this expert judgment to judgment your content validity. Okay. That's about the content validity. So concurrent availability is already mentioned about this one. But for the content validity is here. So panel 1 to panel 6. Panel 1 to panel 6, we call the judgment expert. Okay, the judgment expert. For the PhD level, hello Nijal. Okay, for the judgment expert, we need at least 6 panel. 6 panel to measure your content instrument. For example, here we have the 3 variable here: professional learning leaders, rules. Second one is professional learning models, and 3 is teacher practice. So the panel, the 6 panel will be measure of 3 of these variable to show that the variable is accurate for the content. So how we know that the content is valid? Based on the value here. Based on the value, the value range from is 0 to 1, where the item CVI, if the CVI higher than 79, the item will be appropriate. If the item between 70 and 79% is need revision. If it less 70%, it is eliminated. So from this category, we found that is more than 79%. 79%, the item or the construct is appropriate. That means all the variable is valid to measure of each of the variable. For example, variable 1, professional learning leader, is more than 90% or 80%. And cumulative from the 6 panel is 86.2. So very high, more than 79%. So this is from the judgment expert for the content validity. Okay? For the content validity. Okay, we go for the construct validity. We're using the factor analysis. Okay, so this is the factor or construct. This is an item A, B, C, D, and so on. And so on. So factor analysis is summarize and data reduction to allow us to take a large set of data and make it more interpretable. That means you have a lot of the item. We need to summarize and reduction. Okay? This is very important because sometimes the item is not suitable for the respondent. So we need the EFA. Okay? So this is basic how to process based on the SPSS. Okay? Data screen, you screen data, any problem or no problem. Extract factor, how many factor you want to extract. But sometimes I just leave it. Let the SPSS conduct how many factors they can produce and rotated factors and interpret the results for each of the construct. This is a procedure. You must be fulfill all of this criteria, especially for the construct here. Number 6, minimum item per construct. It's a minimum 3 per construct. It's more than it's okay, no problem. Okay. Okay. Can you open the organizational culture data for the run the factor analysis? This is data. Okay. We go to the variable first. Okay. The item from ID to A to X. So the label is here, risk-taking, collaboration, hierarchical. So these items is refer to the culture in the organizational. That they have the risk-taking, collaborate, hierarchical, procedure, relationship-oriented, result-oriented, creative, encouraging. So there is the item in the culture in the organization. So we want to check any item is reliable for the teacher. For the teacher, so what to do? We run the factor analysis. So you go to analyze, go to dimension reduction. From the dimension reduction, you click the factor here. So from the factor, you select all the item except the ID and bring to the variable. Right? Bring to the variable. Okay? All the item. Okay, click description. You need check univariate description, coefficient correlation, and the most important is KMO and Bartlett test. What is the KMO and Bartlett test? I will discuss about this one after we run this one. Extraction, we still using principal component. Okay. The rest no need to change. Rotation, yes, we need rotation to Berry-Max. The common procedure in the EFA for the instrument, we using the Berry-Max compared from the direct application or Promax. And display loadings, click loading. Score, no need. Option. So option, we click here. Sorted by size and surprise small coefficient. That means we don't need the item below what number. Normally, the researcher asks 5.0. Continue. Okay. Okay, this is descriptive. It's okay. There is no funny. We have that 127. Okay, for the factor analysis, some researcher using at least 100 sample to run the factor analysis. Okay. Minimum is 100. Okay. However, it depends to your the total of item. Okay, the total of the item. Where I assume here I using 127 item. Okay. So this is a correlation matrix. Any problem? I think there's no problem. There is no negative correlation. Okay. So this is the KMO. So KMO should be more than 0.5. It's more than 0.5. Looking here. Yeah, this is KMO is more than 0.5. Okay. Based on this, more than 0.5. Better significant, significant or not significant? Yes, this one is significant. Eligibility one is over. Okay, we go to the item loading. With more than 0.5, the factor analysis value is more than 0.5, and mass minimum item per construct is a minimum 3. We go to here. We have the 66. Okay. Look the component here. Okay. When you look this one, the rotated component matrix, we found that some the item is not show the value. For example, yeah, sociable. That means the item factor loading is below 0.5. 0.5. Secondly, we found that some item is redundant with the other component or construct. So what we to do, normally I will be delete this item, redundant and no value is here. So how to do? Go back to the factor analysis. So what item we want to remove? First, Cautious. This one. Bring back to the item. Secondly, sociable. There is no value is there. This is soluble. Here. What another item is redundant? Challenging. And power oriented. Okay, we run again until we don't have the no more redundant and no more item is no value. So this is the second time we check. We step here, two item here, collaborate and structure. We try again. Remove the item, collaborate and structure. There's still for construct. Run again. Lastly, we have the three construct from the construct. So we still have the redundant item and no value here. Okay. So we remove again, encouraging, regulated, and trusting. Okay, this is the panel one. Okay, the panel one, we found that the construct number one represented with 6 items. Construct number two represented 4 items. And the last one with 5 items. So that means after we run the picture, we have the 3 components. We have component here. This one. And after this one, we need to rename each of the component or construct. So number one is referred to what? Result oriented, procedure, created amount, having result order restrict. Okay, number one is more to creative. creative culture. Okay, creative culture. Number two is about more to the bureaucracy culture. So the hierarchy is there, order, phrases, risk-taking. This is a more to the bureaucracy. And the third one is more to the supportive. More to the supportive, personal freedom, equitable, established. Or sometimes you said it's about collaborative culture. It's up to you. It's up to you how you interpret each of the item to refer to what. This is more creative for me. Okay, it's more creative. One, number two is bureaucracy. Three is maybe it's a collaborative or supportive. It's depend to you. So that's it. How you run the factor analysis to show that you can be reduced from the 24 item maybe to the 18 item or 17 item. Okay. So this is for the PhD student and PhD student. For the master student, you don't need to run the factor analysis. Just enough to run the content validity. Okay, the content validity by the expert judgment. Ready how you try to write up for the factor analysis. And now last about the regression. Okay. Also, this is a method regression normally for the student PhD also because of the very hierarchy for the analysis. However, the regression actually is a more simple. Yeah, it's very simple actually. But you need to fulfill the requirement and you must understand how to interpret the regression from the interpretation by SPSS. Okay? So regression, we have simple and multiple. Simple and multiple. So what is regression? Regression is process estimating. You estimate the relationship between among variable. Okay? Widely used to predict and forecasting. So what is different about prediction and forecasting? So normally forecasting is for the weather focus. After you check every day weather, so you can forecasting. But prediction, we don't know either from the previous event will be same what will happen today. So that is the prediction. Okay. For example, forecasting is more to series and futures, while prediction does not. Not about the series of future, but what will happen today. Okay. That is a regression. There are three types of regression, but normally I teach for the simple regression and multiple regression. For logistic regression is okay, but we need some data to show that we need a logistic regression. Okay. So for our workshop is we using simple regression and multiple regression. So when you use the regression model, you need to write up the model or the formula here. Y equal to beta plus beta 1 x and plus error. So Y is referred to dependent variable, or in the regression we call the response. Response variable. X is an independent variable. Y is dependent, X is dependent. Okay. Error, this is referred to error term. Okay, error term. So what is our assumption? In the SPSS, we're using 5 of these method to show that you have fulfill of the pipe assumption here. First is about relationship between two variables should be linear relationship. You can use the QQ plot, or scatter plot. Second is residual should be approximately normally distributed. So you use the Dobson-Watson. Okay. The value should be between 1.5 to 2.5. Okay. Number three is no multicollinearity. That means a relation between two variables is not higher more than 0.8 or 0.8. But sometimes they're using another indicator we call VIF, tolerance, and CI. Okay. The fourth one is about the outliers. The data is there is no outliers, so you're using the standard better values. The value should be between -2 or positive. If more than that, you have the outliers. Okay. And the fifth one is about heteroscedasticity, unequal scatter residual between variables. So maybe you use a PP plot. The other one is QQ plot. So we run the QQ plot and PP plot. Okay. So it's very basic. In the classroom, normally I will ask the student using their data, not my data, because my data is dummy. So this is, for example, the QQ plot. Plot. Okay. Okay. The second one is heteroscedasticity. Why heteroscedasticity? Because there is no pattern. The dot is distributed anyway. This one is very bad because we have the pattern here. From the small one, so the heteroscedasticity is very bad. So this is the how you use the Dobson-Watson table. The Dobson-Watson table. Okay, remember the minimum is 1.65 until 2.35. So we're using this one. Okay, can you open the employee data? We try to open the employee data. So here, show our data. Okay. So, for example, here we try to predict either the salary beginning will be influenced to the current salary. So, how to predict? Go to analyze and go to regression. Click linear regression. Okay. What is dependent variable? Dependent variable current salary. Independent variable is beginning salary. So statistics. Yeah. Descriptives. Dobson-Watson. Remember Dobson-Watson? New plots. Jet receipt. Quality probability plots. Okay. Steps. Go to here. The add betas because they add beta to show that your data is not loud. There's no outliers.
所以我也不想搭理他。他如果在这样的话，我肯定会跟他说的。我说：“亲爱的，咱们可不可以有点边界感？”
Option is okay, no problem. Style is okay, no problem. Bootstrapping. You need the bootstrapping? No. Then we run. Okay, we have the 474 respondent. Okay, look for the correlation. We found that the correlation very high, 0.8. Remember this R here? I mentioned before this, the small letter R and capital letter. So capital letter R in the regression also is referred to the Bayesian correlation. Okay. But the most important here is R square. R square is 0.77. That means around 75%. Around 77%, the current salary was influenced by the beginning salary. Okay, this is the current salary. So the beginning salary was influenced the current salary. Okay. How much is 77%? Okay, remember the double Watson here? We have 1.8. This one. So you have the 1.8, that's mean between 1.5 to 2.5. That's it. Your data is normally distributed. Okay. So ANOVA here, once again, ANOVA is a significant. That means quite different. It's very quite different when the beginning salary was influenced the current salary. Okay. So the coefficient here is significant, 0.3. So this is residual, it's no problem. Look for the item here. This is a PP plot. This is a QQ plot. The QQ plot is not problem here. Okay. No problem here. Okay. We go to this one, outliers. How to check the outliers? You go back to here. You run analyze the distinctive. Click here. This one. The minimum here, maximum here, 1.5, 1.0, and minimum 0.4. So your data, based on your data, your data below -2 and below 2. So there is not outlier. There is no outlier in your data. Okay. It's okay. Okay. Already there. And don't forget this one. This one. Your model. Y equal B beta plus B1 independent plus E. But from here, we don't need add error term here. You just click current cursor. This is your beta constant plus 1.9. This one for the winning salary. Okay. Your R square 0.077 and so on. Okay, multiple regression. Multiple regression does mean you add another independent variable. Okay, you add another, for example, for example, first, simple regression, x, y influence to y. But if you have the multiple regression, you need another variable to influence the y. Okay. So how many maximum? Normally is 5 independent variable. Okay, for example here, beginning salary, months saya, previous experience. So we go back to our data, run again, regression. We need months and higher and previous experience. The rest is okay because we already checked in the if of each of the value in the sub menu. So just click OK.
Logo had you stated in 2022 of the PROF.
Okay. Look for the correlation. Look, the previous experience is negative. Okay. And also significant. Okay. Double was 1.93. So there is normally distribute. Okay, from here we found that all the variable is significant influence to the current salary. How much? Go to here around 80%. 80% each of three of variable was influenced to the current salary. So which one more the highest? We are going to the T value here. The value we found that the higher is beginning salary. Second one is a previous experience, and the third one is months and higher. Remember, the previous experience is negative. Okay, it's negative. Okay. So, look this one. Negative, 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 positive, and negative. The most important is there. Okay. Based on the T. So this is how you write up your multiple regression. In Bahasa Melayu, it's a quite different to interpret based on this one. But in English, normally they use this one method to interpret the multiple regression. Okay, that's all, folks.